we can take it away.
All right. Thank you very much, Ross. And thank you everyone for joining this evening. I'm Narendra Rao here in Chicago area. Been here about 35 years and I know Chicago pretty well. Um, Glad to be here. I've been with Couchbase for about coming on close to 3 years now. Prior to that, I was at Oracle, Dell Tech. And before that, I was an independent consultant for 16 years. Worked at some local companies here as well in Rogers Park. So I'm pretty much a Chicago native. Worked in the surrounding states as well as part of my independent consulting work up in Wisconsin, Indiana, Michigan, and so forth. So pretty much a North Central guy. And for a couple of years at Couchbase, I worked as the North Central solution engineer here, supporting the sales people. But my background has pretty much been in the ERP space, not only that, but also from the implementation, database, as well as project management as well. So glad to be here, and I'm going to share my screen and talk about Couchbase. Can you see my screen?
Sure can.
All right, so let me put it on start, and I will not be able to see messages that come by because I'm not sharing my other monitor here. So Abhijit or Sean, if you can look at the chat or answer questions, meanwhile, that'll be very
Yeah, I'm
helpful.
monitoring. Excuse me, don't mean to interrupt, but I'm monitoring the chat as well.
Sounds good. Thank you very much.
Thank you. You're welcome.
All right. Thank you. Today, we have with me not only Sean, who you got introduced. Sean is our enterprise sales executive. We also have Abhijit Behra, who is my colleague here out from Minneapolis. He'll be doing the demo at the end. And I'm a senior customer success engineer. I've been at different roles in my life, but this is a new one for me, but it's been very interesting. So to say, it's different from customer success manager. It's more like rolling up your sleeves and getting knee deep into the problems our customers have after the fact, after buying and implementing the product. So just to give a quick overview, our North Central US Couchbase team, like I mentioned, it's me, Narendra, and Abhijit. There's another guy, Vijay. He's also in Minneapolis. He couldn't make it to this conference today, so I didn't put his name up here. Along with us here is Sean, and Dan Nicholson is on the phone. Dan is a longtime Chicago, Ohio guy who is also the major accounts here in the Chicago area, like United and other larger ones. And Michael Mills also is in the Chicago area, who has another set of accounts. Both Dan and Michael and Sean cater to all the entire North Central. That means all the way from Minneapolis to Wisconsin, Chicago, Indiana, Illinois, and Michigan area territories. So with that introduction, with that marketing splice, let's get into the deeper part of it, but still a little bit of marketing here. Uh, Company background, Couchbase, right? Pretty much not many of them have heard it. They confuse us with Coinbase and other databases out there. But realistically, we are one of the uniquely positioned. Couchbase is uh, a departure from your traditional relational database. It was formed in 2011 because there were some inadequacies that came up as part of the relational database. And the requests that was coming by ended up with the founders that they said, okay, we need a flexible schema architecture. We need a faster database to get uh, our results out, and also a very flexible way of querying data and sub-millisecond response time, kind of thing, and a much flexible developer-centric database, right? So thus formed. At the same time, there were other databases also being introduced in the market, but NoSQL JSON database took the footholds. It's a departure from relational world, but relational has still, for the last 40 plus years, stabilized themselves as the transactional database, right? The better part of it is now with Couchbase, you don't have to go to a relational database. You can do everything that relational database does plus more. Now we'll see that as we progress to our presentation. So what does Couchbase mission statement stand for, right? It's a modern distributed memory first application. It's not a database, it's a data platform. So with the power and familiarity of SQL, that means if you have done SQL in relational database, you can bring that skill set right away into and start using it day one. The first hour after implementation, you can use the same SQL language, ANSYS SQL 92, and get the data out of your database, which is stored in a JSON format. Very interesting. Plus, beyond that, we also have a DBaaS offering. That means it's a fully managed database as a service in the cloud that runs on any one of the public clouds, right? Whether all the three major clouds, plus including we are looking at IBM and Oracle as well to be on the roadmap. So where do our customers use our product, right? What are the different use cases? As you have heard, most of the databases are driven by use cases. So retail, right? Like content management, inventory, manufacturing, right? User profile and customer 360. And also in today's world, IoT, right? Sensor data and also Fitbits and things like that. All of these medical devices that you need to manage using your app, all of these have Couchbase in them, in the sense that we not only have a server-based database platform, but we also have a mobile platform that helps you use the embedded database, which is called Couchbase Lite, that sits within your device and does the same kind of capabilities, provides you the same kind of capabilities that you can do on a server with the same SQL language. You don't have to learn a new language, that you can use the same SQL format, query language, to query the data. We'll see that later on. Abhijit will demonstrate that real time on an Azure platform. So who are our customers, right? So most of our customers are the ones that you use every day, right? Look like LinkedIn, American Express, Comcast, AT&T, Amadeus. Amadeus you might not have heard, but it's a big European-based airline reservation company that powers all the reservation systems, just like Labor, right? Sabre and Orbitz and things like that. So behind the scenes, Amadeus does this humongous reservation management system for it, and it runs on Couchbase. Very large clusters they manage behind. It's all Couchbase. So just to give a NASCAR view of which verticals we are deployed in, pretty much everything, right? If you think about it, right, whether it's retail, travel and hospitality, finance, healthcare, telecom, industrial IoT, everywhere Couchbase can be used, right? For example, Tesco, the largest grocery chain in EMEA, right? It is bigger than, as close to Walmart. It's called the Walmart of Europe. They use it. Actually, one of those Black Friday days, they had a meltdown in Oracle. They could not move faster out of Oracle to Couchbase. And since then, they have been very stable because Couchbase is not a single monolithic structure. It's a clustered database, and it has highly availability built in. Plus, you also have replication capabilities, so you can switch your application if one of the cluster fails, which is very hard to do, to a secondary database. Staples runs the entire catalog. You want the one you go in and the e-commerce and you put in, and they have about 3 billion rules that power all the intelligent offerings that you get when you put an item in a cart, you sit there for 20 minutes, suddenly it pops up and says, hey, if you buy it now, you got 20% discount. All of those intelligence built on Couchbase using eventing functionality. Same case with, just to look at a healthcare, right? Becton Dickinson, BD, right? Your mobile application that captures your device information that for your diabetics that goes captured and then sends alerts to the doctor's office based on your readings that is configured for your app. That's run on Couchbase Lite that sits on the mobile device that runs the Becton Dickinson application. And same way with gaming. Gaming is a huge thing, very fast, really quick, sub-millisecond response time, right? That is powered by Couchbase. So Chamberlain, right? Chamberlain, you may know, who does your LiftMaster and other different garage door openers. Not the garage door themselves, but the openers. Especially now with with the MyIQ powered application, you can open your garage door or shut your garage door anywhere, wherever you have access, internet access or Wi-Fi access. You can do that, and that is all powered on Couchbase as well. So things that you use every day behind the scenes, whether it's United app or Sabre reservation or Hilton reservation. All of these are powered using Couchbase, and you don't hear about them because it's behind the scenes powering the applications. That's the modern applications that are constantly being built on Couchbase. So with that architecture, do you have any questions, or shall I go into the architecture view? This is much more interesting, I guess, for people who want to understand how Couchbase works under the hood. If anything, please stop me, all right? So we already established that Couchbase is a document database, a JSON stored data. What is that? How is that different from a relational database, right? In a relational database, you have a table with rows and columns, and your data is stored in rows and columns tuples format. In a JSON document database, your document is stored, your data is stored as a document, right? And it's stored in JSON format, which is an evolution from XML, much more faster, much more easier to manage. So why is that better, right? So let's look at that. Let's look at the different ways of data that is stored in a database can be queried, or so to say, inquired, right? So data is stored in a database, but there are multiple ways of getting the data out. The fastest way is a key value store. That means when your data has got a key, an ID, value, which is a hashed value. When it's stored, it's the fastest sub-millisecond response time that you can get. That means you don't even have to go through an index. For example, a key value is an ID, like an email ID and a password. That could be the fastest way. Apple runs on Couchbase. Apple login, Apple ID runs on Couchbase, right? It's also a distributed SQL database. That means traditionally, you know everything about relational database using query, which is your most transactional systems. That can be done as well with ACID transactions. You can run your transactions like in Oracle, begin transaction, run your script, and then end transaction, rollbacks, save point. All of these capabilities are built in Couchbase as well. And then also a search engine. It can run a search engine by itself as a full text search with an inverted index, or you can use the same search in conjunction with SQL. You add that search component of it. Now you have a very powerful search capability. That means, think about it. You're in Chicago. You want to need a hotel on Lakeshore Drive. It has to be a walking distance from Navy Pier. It has to have a restaurant, free breakfast, gym, free parking, and so on and so forth. And it should be on the second floor, whatever, right? All of these if, then, else, and questions. You can put that in using that same SQL plus, we call it SQL plus plus, which is an evolution from SQL. And you can get that in seconds. Very powerful search engine. So where can you use that, right? Like log analytics, right? Website search and so on and so forth. And our fastest growing segment is our mobile. Now, pandemic did help, but even before pandemic came in, our customers were using mobile. For example, Dow Chemical. They had all their data in silos in SAP. Now the factory floor, they have to go to a desktop to look at their drawings or images and things like that. Very slow process. People come and change shifts. Much easier was they built a purpose-built device, Samsung device using Android, Xamarin app, or today it's called .NET. And they now can access all the data that's inside their SAP data by using our Couchbase mobile architecture. Well, we'll get back into that a little bit more, but the fact of the matter is our Couchbase mobile architecture runs in a disconnected format and syncs when it's needed with only delta sync format. That means there are no other product out there that will let you do that kind of scenario. That means you can go and use your application in a disconnected format where you have no Wi-Fi, no internet, and still be able to use your application without a problem. And then when you come in range, your data range data will be synced back to your central database, whether it's in the cloud or on-prem or multi-cloud, wherever it may be. The key factor here is that in between you have a sync gateway that does all this work for you. Conflict resolutions, who wins, who loses, all those kind of things are built in. It's a very intelligent way of syncing your data from your handheld device, your Couchbase Lite, back to your central database. Plus, built into the same cluster, you have another service, which is analytics. Now think about this, right? Real-time analytics. Think about Oracle, where they call this OLTP OLAP into a single database. If you run your OLAP application, right, it will definitely hurt your your OLTP application. That means you'll see the performance hit taken on your transactional application. You don't see that here in a clustered environment because the analytic applications service it runs on its own engine, right? It's its own engine. It's a parallel processing engine. It runs its own cluster, but the data is real time. In other words, you don't have to wait for an ETL processing to happen. Your data comes as it comes into the database immediately based on your rules you set up. It makes it available to the analytics engine as a shadow data set. And now you can run your very, very heavy or ad hoc query and not even have a blip of an impact on your performance on your existing transactional applications or your KV application, which has got sub-millisecond response time, right? So we'll look into that a little bit more. This is a very high-level overview of the different services that you get in Couchbase when you install it. Now, do you have to use all the services? No, you don't. You can just use it for KV. You can use it for KV and just query, or you can build in search, or you can add those functionalities or activate those inside services at a later point in time, right? So very flexible for our customers. All the capabilities that you want in a singular database. And you must have heard of about all this, polyglot persistence. The pendulum got swung to one extreme, and people started when microservices became popular, they started saying, okay, we have a different database for a different use case and different SDKs. Suddenly it became a database sprawl, application sprawl, skill set loss, all kinds of issues came up. At which point Couchbase became very, very visible from the point of view that it can do all the different functionalities in a singular database with a multimodal database with a variety of SDKs that you can write to access the data. Any questions? Okay. So one of the best ways of understanding the internals under the hood of Couchbase is to look as a singular node. Now, do we recommend installing Couchbase in a singular node? No, because you don't have high availability. You can't manage load. You can't do a lot of things. But to understand Couchbase, let's look at a single node. And for development, sure, run a single node, right? But for production, you need a minimum of 3 nodes. And if you have more than 1 or 2 type of services, I'm going to go talk to that. There's much more architectural capabilities that you may want to use. So looking at the single node, as you can see in the red box, below here is a data, index, query, search, eventing, and analytics. Now, we haven't touched on eventing, right? Eventing is akin to what you are familiar with in Oracle or SQL Server as like triggers. But this is much more than a trigger. This is trigger plus business logic plus workflow all built into one, written in JavaScript. That means you are bringing the functionality of an application developer right at the database level. Now, will everybody want to use this? Some people are scared of giving all that kind of functionality into a database administrator capability level, but people do that in Oracle, right? So it's a toss-up. Where do you want that logic to work, whether it's at the application level or whether it's at database level? So everything in database design goes with the use case and how you want to build your application, right? So everything has a place, and everything is a decision and analysis part of it. Nevertheless, we have these different capabilities which you are quite familiar with from just the relational or any other database concepts, right? Now, we can run Couchbase on any public cloud. We can run it on-prem. You can run it as a hybrid model, multi-cloud, any container, GKS, AKE, whatever out there, Docker, right? Any of those containers. Plus, we have a Couchbase autonomous operator which can manage if it is running a container, which manages your Couchbase, installs it, manages it. You can do your monitoring, and all those kind of capabilities are built into using our Couchbase autonomous operator, which is of no cost, available to you when you install it in a container. And absolutely, we talked about being very consistent. That means ACID transactions can be easily supported. That means you don't need to go to a relational database to get a transactional database. You can build that using even your banking and fraud analytics. Everything can be done using Couchbase. It's a memory-first architecture. What does that mean, right? It means your data that comes in first gets read into memory, gets proliferated across your cluster on your data nodes, and it's available as resident in memory. At the same time, you have zero data loss. That means there's always a persistence layer that manages it for you without having impacting your sub-second response time, right? So not only that, security obviously is a big component of any database. We are a database company and security is paramount. So we have a lot of security built in, whether it's TLS 1.3 or whether it is role-based access control, right? All of this are very well integrated. We do not buy products and cobble it together. We build our own products. That means we do not have outside products coming and trying to fit into Couchbase, right? We build our own. At the same time, on the other hand, on the right side is the purple box. We have integrations, we have connectors that you can connect to any big data lakes, S3s, blobs, Google Lakes, and so forth. Our analytics engine has got access, has capabilities to remotely link to all of those data lakes. And with the same SQL++ query you run and the ad hoc query, you can traverse across in the same SQL statement, go to S3 or Blob or Google Lake and get the data and present it in a tabular format or any other format that you want to display. And all the leading industry, all the industry leading SDKs, 10 or 12 of them we have, I know we do at least 12, are supported using on Couchbase. You can, our developer SDKs, we built it, and then you can use it to build applications on Couchbase. We also have access to REST APIs. Our APIs are exposed, and you can write a lot of, you can access our database through APIs as well. Plus, our managing of the database is done using consoles, using our console, and which you're going to see real quick in a few minutes. Using Abhijit is going to demonstrate that for you. So, any questions on the cross section of a single node?
Yeah, I have one.
Okay.
So in a single Couchbase database engine, how many Couchbase databases can I have?
So you can have it. The concept is on the way it works is you create something called a bucket, right? So based on the bucket, you can have tenants, right? So you can make it like when you're I know where your reason you're coming from SQL Server kind of concept where database, right? So for a schema is a database. So the same thing you can do that in Couchbase. We have same thing called scopes and collections. Scopes would identify you as a tenant, and the collections will go underneath the scopes. So each of them could be a database as well as and can be uniquely isolated from the other without having to step on each other and insecure.
Okay, well, that leads me to my next question. And that's this is recovery. Now I know you have the failover part covered with the multi nodes, what have you, but the recovery I'm talking about is that somebody calls me up and says, "Hey, I accidentally deleted a bunch of data. I need that data put back." Now, I want to be able. Can I recover that data in that one engine or bucket or whatever you call it, without affecting the others? In other words, I don't have to recover the entire instance to a point in time.
That's correct. So what you do is we have something called cross data center replication. That's a part of the business continuity and high availability or DR scenario, right? So let's say you have a cluster with 3 nodes, but you don't have to have another cluster with 3 nodes. You can have a cluster with a single node, and you set up a replication such that it's available. It gets replicated to the secondary data set, right? So data node, or your cluster, so to say. So it goes at the speed of your network and asynchronously. So pretty much we have seen it is seconds, it gets available on the other side. It's available all the time as a completely standalone DR situation or business continuity situation. If you delete a record, right, and if it goes into that area and if it deletes as well, then yeah, you kind of have a little bit of a data loss. Let me ask Abhijit if Abhijit there's a little bit of work on recovery side. Abhijit, do you have a scenario where a logical deletion of a particular collection record, if it's deleted, is that recoverable from the point of view?
Yeah, we can, because there are different backup strategies and all how you implement, right? We can do backup and restore as well. But in terms of the example that you laid out, right, the cross data center replication. So let's say we are doing just unidirectional replication. Let's say there is an active cluster which is taking all the requests from your application. So you are writing to that particular database, that is your primary, and you have something hot standby, right? So you delete something here in your primary database. So that is replicated to the hot standby as well. That gets deleted. But on the other hand, let's say you're having a setup called as active, both the end they are taking in the request. So first come, first serve basis. So let's say you're deleting one active, deleting on the active cluster, and the another active cluster, it's not yet deleted, but it will get replicated. So it depends on the situation, how we want to handle it. But long story short, if you want to recover, well, you can always recover from your backup and restore.
Yeah, you don't have to recover the entire cluster. You can recover the deltas data only for that bucket. Filtered data for the document.
Yeah, you can definitely restore it to some other location and definitely extract that document if that is so important to you.
Right. So what people have done is create another bucket, and then in that they dump the data and only move the data from that temporary bucket into the bucket where you want the data to be. The other key differentiation here is that, which I have seen even in Oracle ERP situations, is even though Oracle has got referential integrity built into that from child to parent scenario, all the entire ERP applications are never at a database level. They are managed referential integrity. It's all programmatically done for reasons beyond, because as and when they develop the application, the RI component was managed within the application itself. So that concept has traversed into most of the NoSQL databases in the sense that now a lot of these RI capabilities are built within the developer's realm. The developer built applications, they can manage the referential integrity perspective from that way. So you are not going to see in a document database an RI type of a situation because it's a flexible schema environment where you do not have it just hinders the RI, it just hinders the development and the speed of microservices development. So the RI capability has been not moved into any one of those document database, whether it is DynamoDB or anyone that's out there, whether it's Mongo or anyone. They don't carry that RI capabilities into the database structure. It's a different mindset coming in from relational, trying to understand, but there's a reason and a place for where a document database and JSON database fits into the use case.
Okay, so to recap, to recover from an accidental deletion, I would do a recovery to a temporary bucket.
Correct.
And that temporary bucket, I can do a point in time recovery to the point in time before the delete occurred.
That's right. Yep.
Yeah,
And
using
then
the backup.
And then copy the data from there to the real bucket where the data was accidentally deleted.
Yeah, that's
Exactly.
accurate. Yep.
This is
Okay.
exactly what I would have done when I was at Oracle DBA. I used to do a create table as before I manage my original table. I would create a backup, and then if something happened, I would be able to select insert from the backup table into the new table. Exactly the same principle here as well.
Okay, but in this case, I would want to do a restore to this bucket.
Correct. Now, there are ways to get around it. Like, for example, if you think there's a bucket that is very, very critical for you and cannot have, any, cannot lose any data, whatever, and then you think your application has risk losing data, what people do is they run an eventing program, right? And then they create another bucket. And as and when your logic or whatever, right, that meets the intent, it creates an eventing trigger and then populates the second bucket, right? And it's always data is available there at any given time.
Oh, sure.
yeah.
That's could do it that way too.
Yes.
But as a rule, and this kind of thing doesn't happen all the time, but I can tell you it has happened, and
Yeah.
the recovery can be, for a database engine, the recovery can be simple or it can be horrendously complicated.
Oh, trust me, I've done that log mining and stuff like that, trying to get a single row, trying to put it in. But that happens when there is a bug in the application. Normally, unless somebody has got access to the data and they go delete it, which means there's a hole in the role-based access control. Somebody has got access to a particular bucket that they can delete it. Otherwise, application-wise, it can be a bug that can delete. Data can get corrupted. Yeah, anything is possible. You're right about that, Ross.
Well, yeah, I mean, in a perfect world, we've designed the application so that there's never a need to get at the data.
Mhm.
But you and I,
Yeah,
and the rest of the people attending here, we all don't live in a perfect world, and so there's always going to be times where you have direct access to the data, and they'll run SQL or whatever you call it here to delete something. And in the process of doing the deletion, they thought, oh wow, I forgot to put a where clause in there.
that'd be a bummer.
Oh yeah, big time. And then everything's gone.
As well, yeah.
And
Thankfully, we don't have truncates yet in any NoSQL databases because truncates, we have something called flush, which would flush the container, which is the table level. But yeah, currently, if you have not implemented a particular version of Couchbase, you have flush at the bucket level, which is it can be, you can empty your documents, right? So exactly, I'm with you on that one. Mistakes can happen, right?
Yeah,
but
that's why we take backups, and there'll be
Yeah,
incremental backups, right? You don't
yeah,
need to restore the full database, just incremental hourly or half an hour, because we have to decide
exactly. Yeah.
how much data you can afford to lose, right? How much time. So
yeah. Yeah, thankfully, Ross, in my 3 years at Couchbase, I haven't heard any other, but I hope I'm not going to hear any more of somebody of my customers opening a ticket on that front. Yeah, it can be painful. I agree. So moving along on this particular topic, right? We talked about cluster. Cluster is a bunch of nodes, commodity nodes put together. It's not like a single Exadata or a very expensive HV box or any of those Reliance or things like that, right? So you basically have commodity nodes cobbled together, and what we have in between is something called the data change protocol stream. That is the spinal fluid that connects, that talks to all of the different services that we mentioned, whether it's KV, data KV, or query, index service, analytics, full text search, eventing. All of them subscribe to this DCP stream. So what you see here is from node 1 to node 11, a bunch of a cluster. In that, you see different services across multiple nodes. That means for the data services deployed across first 3 nodes, a different shape. And then you have query and index together on 2 different nodes, 2 nodes together. Analytics normally be like 3, but on here for demonstrations, 2 nodes, which is a massively parallel processing engine. Full text search, same thing on 2 nodes, and eventing. Just to display here, these are of different shapes, can be based on your need, because if you don't have a larger requirement for your KV service, your shape would be smaller. And then for query and index, which is much more heavily used in your situation, it would be a little larger shape based on your size of image. Why is that important? Because number one, it reduces your cost of ownership, right? If you think about this deploying in AWS, they charge you by the shape, right? And also, we call this multi-dimensional scaling. Now, if you want to add, let's say you have a requirement, let's say you are running your peak at that point in time, and your index service and query service, people are running much more query and stuff like that. You can add a node and remove a node as and when you require, right? Uh, and especially when we talk about database as a service, which is our Capella offering, Abhijit is going to show you how that can be automated. You don't have to add it. It knows when to add, and then it knows when to remove it. So as you can see, the different layers, this is very typical diagram view of an on-premise implementation where you have different SDKs. Like you have, let's say, um, something.com, your main application, occ.com or whatever, and then various applications contribute to it or uh, run off it, right? So some could be written in Java, some could be written in Node, Python, Net, whatever applications, right? These are all microservices that can access your cluster in different ways. So there is no limitation on how you can write your microservices application, which could be a one .com application. There could be multiple languages, multiple SDKs written in, and behind the scenes, you have a platform that supports all of those in different services without impacting performance, and highly available and built-in BCDR, business continuity and DR, by cross-data center replication. Very powerful architecture. So let me see here. Okay. What you see here is a horizontal view of what happens underneath the hood, right? So as on the left side, you see a whole bunch of SDKs that are very prominent, very in the industry. You have all the way from, I don't see Spring here, but even Spring, add Spring to that. Python, Java, Node, .NET, PHP, Spring, Go, all of those are supported. This is all SDKs we support and are kept up with every release of Couchbase cluster, cloud-based server. And as you see, it's a JSON document that contributes to the data service. As soon as data is available, whether it's through Kafka or whether it's through an application, the DCP stream sends data across the spinal fluid, right? It goes across all the different services, and the services wake up and do their job, do their thing. So it's very quick behind the scenes. They're all subscribing to the data change protocol stream. So as we talked about all the different services on the left side. On the right side, we talked about the analytics service, which is also a filter process, because you can filter only the things that you want from the data service, or you can have all the data come by, right? But the key here is that you are not only using the data, operational data that comes in, but also data that is available in S3, Blob, and Google. Like we just talked about that, how we can, with a single SQL++ statement, you can get the data not only from your OLTP shadow data set, but also from the the lakes that are out there, which most people use these days. And also the connectors we talked about, how we can bidirectional connectors with their Kafka streaming and sending, sync in, sync out, those kind of things that can be managed as well. Eventing we talked about is a very powerful JavaScript engine that has business logic as well as workflows built into it. We just touched on cross data center replication. Cross data center XDCR you see on the top there on the orange lettering. That gives you the capability, right? That's at the speed of your network, makes data available anywhere in the world or within your limits, within your geographies, within your availability zones, however you want to configure it, with built-in intelligence for conflict resolution, or you can put in your own business logic based on your conflict resolution, who wins, when it wins, what it does. Normally people do it's too straightforward, bidirectional, but if you have specifics, reasons, let's say, oh, okay, I have a cluster in Europe, but the HR data cannot leave Europe. So those can be filtered. Only the buckets that need to be sent out can be done. That doesn't leave the borders. A lot of reasons why you would filter out a cross-data set replication as well. That's why you see the filter mark there as well for GDPR and whatever reasons you may have. across the global deployment. At the very bottom, you see that the transactional and the operational, as you see to the left side, mostly transactional operational systems are supported. And as you go to the right side, you see a lot of analytic and Haddock queries that are available, again, in the same cluster inside of Couchbase. It's a very powerful platform for you to use it. Very simple to install, very simple to use, and highly available. Really quick, going in here, what you see on your left side, the dark blue, is the relational format. So if you want to move from a relational to Couchbase, it's pretty straightforward. You can do one-to-one mapping from a customer to a customer collection, and then your data comes in as a document, right? So there's a lot more we can go into another session when how we do the data modeling, but it's good to remember that you can, for a simple application, it's much easier just to map it one-to-one, and you bring it into Couchbase, and then you can start using it right away as a document database in a JSON format. It stores data in a JSON format. Now, when you come to Couchbase, when you look at it, you have to probably, everything has to be remodeled in the sense that just because you use it in relational database doesn't mean it's the way you want to come to Couchbase. What's the big advantage, right? If you're not going to remodel it. Now, the whole concept of Couchbase in JSON and document database, or any document database for that matter, is the model is based on use case. Now, use case requires saying, hey, I need this in sub-milliseconds. My other ones, I don't need in sub-milliseconds. That's how you model it. And then it's all based on your requirements and what's the speed of for your data you need and high availability and things like that. So and also your multi-tenancy. In a single cluster, you can have multiple tenants without security compromise and no noisy neighbors. Works pretty well, and also totally reduces your cost of ownership, much more than any relational database can do for you. This is a very simplistic view, but majority of the time we end up doing a little bit of a data model based on your use case and then your microservices development. A real quick look at SQL Plus. We've been saying how easy it is to use. Now think about this, right? What you see here in this box is relational. This is a typical Oracle statement. If you look at Couchbase, no different, right? Exactly the same way. This is exactly the same. And you can just go ahead and add your, modify your statement just like that if you want to make your changes. It's called SQL Plus Plus. This is Oracle SQL or ANSI 92 SQL. And then look at Mongo. This is written in JavaScript. The way to get your data out is very complex language you have to learn all over again to get your data out of the database. This is, unless you know JavaScript, it gets a little complicated. Just, the ones that you know for many, many years how to write SQL, now all of a sudden you have to start learning new language. So what are the different support? You can support all the things that you know in ANSI standards, whether it's join, subqueries, nested arrays. All of these queries can easily be written in Couchbase. So basically, what you know for the last 20, 30, 40 years, you can just come in and start using it. Now, moving on to the mobile stack, this is our fastest segment, growing segment, which I mentioned, and pandemic helped in that direction. But even before pandemic came in, it just was the fastest growing segment. The key differentiation here is that you can use our mobile architecture, I won't say even mobile anymore, it's called the edge architecture, because now we have introduced IoTs and other disconnected and very complicated architecture you can deploy, like, for example, retail, right? With retail, you can have multiple stores across globally deployed or even regionally deployed, and you can have a small sync gateway in between. So what's happening here is that from the right to the left, as you can see, the Couchbase server, sync gateway, and Couchbase Lite. This is the intelligent sync gateway that keeps track of what data comes in and goes back. And Couchbase Lite is a small platform, so to say. It's a light database that sits on your device, or an IoT device doesn't need a light database because it just sends bits and bytes. But if you have a data that's to be stored and used disconnected, then it's very helpful to that. Like, for example, Royal Caribbean is one of our largest customers who run these 100 ships across the different oceans that run in. But as you get onto the boat, you get a medallion, right? And the medallion is to you unique, and then it's marked to you. So wherever you go on the ship, wherever you want to order anything, it follows you. They know everything about you and your order, your room, and who you are and stuff like that. You don't have to introduce everywhere your account number and things like that. Once you're on it, it automatically reads you and all that information. And once you get into the waters, right, sometimes you have, you don't have any connections. Satellite connections, Wi-Fi connections are the only one that works. But when you come back into the port or any port for that range, all the data is synced backward. Meanwhile, the data is stored in the Couchbase Lite at the given time. And believe me, you don't lose the data because there are multiple ways where you can secure the data as without data loss. So it's very, very powerful. And then these devices are not one, like 3,000, 5,000 and devices, right, at any given time on a boat. Plus, talk about 100 boats, right? And all of these are floating and all of these are syncing, right, with the central database. So it can handle that kind of volume. It can handle that kind of data that comes in because of the disconnected and the delta data sync capability, right? So at a high level, it is very, very powerful and it's very secure. All data is secure and it is encrypted, and not only at rest but also in transport. Now we're going to show you that as well in the demo. So this is really quick an architecture, how it looks like. We touched on this. This is a singular database. Now, for example, here, on the right side, you see a typical garage location where there are security cameras and then it's connected to AWS. And these days, AWS are not as reliable they used to be anymore because this is a real example where there was a data loss, where there was a disconnection and AWS went down. But with Couchbase, you're still gathering all that information. You're not going to see if somebody's going to go underneath your car and stealing your catalytic converter. You're going to capture that as well in the Lite database and stored. And that kind of video is stored in not only in the Lite database, but metadata is stored in Lite database. But your video could be stored on a different storage device on your existing device or hard drive somewhere. Not connected to AWS as well as a secondary database, a secondary location. So that kind of capability is built into this. So there's always zero data loss and it's always available. And whether it's your computer, like we talked about Dow Chemicals with this purpose-built handheld device, or whether it's IoT devices right on top of Verizon towers. Yeah, these are all data that's constantly being collected across and then stored in the database. It's a binary data as well, or JSON data. And this is a retail example, right? So you have, let's say, I don't know, let's take Kroger, for example. Kroger is in Illinois, Kroger is in Ohio. And if one of their segments go down, right, on here, if it goes offline, they can still operate in the store because the store has got a small the handheld devices that has the office people use. At the same time, there could be we have talked about it. There could be a single Couchbase sync gateway sitting in the store that is syncing it back to the central database, whether it's in the cloud or on-prem. But on the other hand, if this entire network goes down, you're still operational. Ohio is still operational when Illinois is operating as normal, right? And then the P2P sync, the peer-to-peer to sync, you don't need any web or Wi-Fi connection. You just connect from device to device within certain range, right? So if your entire network goes down for whatever reason, you still are able to operate without any issues, right? So this is very helpful in retail, or whether it is in leisure, or whether it is in like hospitals and things like that. So all these devices work in discrete format. Very, very powerful, very easy to build and use, and very secure, and also has built-in conflict resolutions. And this is a very small architecture. We have very complex architecture built into hundreds of locations with multiple sync gateways and HA built into sync gateways. So for example, Royal Caribbean, we talked about Carnival Cruise Lines. They're all ship to shore, shore to ship sync using Starlink satellites. Very, very complicated architectures, but work seamlessly, right? They're using Couchbase.
Yeah, I was going to suggest this earlier, but when you're talking about ships, you want to make sure you're talking about the right syncing.
Exactly, right. So embarking is exactly, the embarking part. Now, Royal Caribbean started to use Starlink, but still, Starlink is still, they have that issue, right? Even when you're middle of Gulf of Mexico, sometimes there's a delay, right? Based on how much data is being sent. It's not as you're connected or in a Wi-Fi range. But we see that, and that's why the conflict resolution comes in, whether your documents are available at that instantaneous at the central server. But most of the time, you need data at the central server in that kind of is during embarkation and de-embarkation, because your passport photographs and all those things are required at that point, right? Your immigration stuff and things like that. But when you're on the ship, you really don't need to sync at the central server because you are working locally in a disconnected format, and then everything happens on the ship, which is nothing but like a smart city, right? That's what they call it at Royal Caribbean. Those ships are big, and they call it like a smart city. It works in a disconnected format very, very seamlessly. So Abhijit, let me stop sharing if I can.
Thanks, Narendra. Thanks for a wonderful explanation. And I hope everyone is not bored enough.
Yeah,
So,
but your part will make it very interesting. Go ahead and show that real
yeah,
live
just to make
association.
it more interesting, yeah, I'll share my screen. Please tell me once you see it.
Yeah.
Okay. So yeah, I've kept it in a side-by-side mode. For now, I can actually expand. Can everyone see?
Yep.
Is it good
Yep.
pixel enough or it's too small? Okay.
Well,
Yeah.
it's
Sounds
kind of
good.
small on my laptop.
Let me see if I can a little bit expand. Is this better?
Yeah. Yeah.
Yeah, that'll work.
Awesome. So yeah, for the demo purpose, I'm just going to focus on our cloud-based database as a service offering. So these days, basically organizations spend less time in maintaining their platform and database, etc. Rather, they focus on actual business application where they can generate revenue, rather focusing on managing infrastructure and maintaining. And of course, this eliminates a lot of other stuffs in terms of resources management and other overheads and licensing. There are a ton of benefits. Uh, just to get you started, this is the login page you see for our database as a service offering, Capella. So here you can log in, and it's a basically 4 to 5 step process. You have to first sign up as a trial account, and you can play around. But for the demo purpose, I'll just log into my account now. So yeah, this is basically the playground where you come here and you can create projects. Like I said, 5 step process. Once you sign up, then next create project. The project is already created, and you need to spin up a database. All you have to do is just click create database and select your provider. So for this demo, we are going to go ahead with Azure, and I'll keep it default region, East US Virginia, but you have other regions available, Canada Central, West 3, US 3, Arizona. And yeah, so you can go ahead and select the region that you want to deploy your database. And the services that Narendra walked you through, that the core database engine comprises of multiple services. So at a bare minimum, we can just go ahead with data, but if you need query capabilities and all, you can go ahead with data index and query. So typically all the customers, they go ahead with data index and query at a bare minimum. And here you can select 3 node. So we do recommend for 3 node for high availability. And this is the lowest size you can select based on your workload. Feel free to choose any higher, most powerful machine available. And then here it's deployed in multiple availability zone, so that if one region is one availability zone, one node is out, then still your other nodes will be able to serve the application request. So in terms of installation or maintaining upgrade patches, anything, you don't need to worry about that because that is taken care of under the hood. All you have to do is, this is what you are going to do as a part of your database creation. Just one click here. That's it. So it will be deployed. As you can see, it's deploying. So it's going to take some time, but in the meantime, I'll go ahead and navigate to the one that is already available. Once it is deployed, you can see the status. Under status, it's going to show it as a healthy, and you can see other stuffs, provider and created by whom, etc., and the latest version. So let's go into the one. Once it is deployed, you get this data tools. Once you navigate, you can navigate to buckets, and this is where you create your database. So if you have used relational and all, Oracle or SQL Server, this is how you create the database that you create there. This is the database in the NoSQL world. Just quick question: how many of you have used NoSQL? Anyone here have used?
A little bit.
Okay. So mostly, I'm assuming relational world. So just so that people understand, this is if you're from Oracle background, then yeah, whatever database you create, this bucket is database. So here I've created user profile. And to make it even simpler, what you can do is import, navigate to import, and just hit import here. So that's going to create bucket automatically with some demo data to play around. So here you go. So this beer sample bucket is created, and you should see the documents. Here you go. You got 4,834 documents loaded for you. Just navigate. You can always navigate here, or you can go and run your SQL queries here. So for the demo, end-to-end demo, what we are going to do is focus on that particular example that Narendra shared with you, the Couchbase mobile capability. That is one of the most powerful feature that we have in Couchbase in terms of syncing the data from your edge location to all the way up in the cloud. So these days, organization face challenges in maintaining data across, like the major hurdle was you got some customer facing database, right? And then you got some backend applications, in-house applications. So how do you sync all this and keep it in one location? And you got database for mobile as well. So ton of data getting generated, but how to keep it in a single place so that you can stream it and do real-time analytics and many other stuffs to get insights as quickly as possible, right? So to give you an example, in the buckets that we created, right? So let's say the user profile, it's a customer facing mobile application. So they are interacting with Couchbase Mobile with an embedded database in the device itself. It's a lightweight version of the database. But how do we stream that data over here? Either you come up with some form of your framework right from the scratch, or use something that Couchbase provides that is known as app service. This is nothing but a middle tier component. All you have to do is configure this, and deployment will be taken care of here. I'm just going to walk you through that process as well. So once you configure that, all you have to do is any Android application that you build, all you have to do is provide that URL and define the user. That's it. You're good to sync up all the way in the cloud database. You don't need to worry about mapping hundreds of fields that you define in the mobile devices or write any custom logic around that. Any questions so far on that? Great. So I'll move ahead. So as you can see, the
I'm
data.
sorry, if I could just ask a quick question.
Sure.
So I imagine that in many organizations, there's some data that should be available to some groups, but not others. How do you segregate and handle data protection?
That's a very good question. So you can create users here. I'll just show you here. Navigate settings. There's a database access. So you can define users with their role and access to a particular database. You can restrict them. Let me just quickly create. So you can select bucket. So let's say there is a bucket. You just want one user to access user profile. You don't want him to access the beer sample. So you just select this bucket. And again, within that also you can provide subset of data like scopes. Scopes is nothing but your schema in Oracle. So let's say you just want that user to access a default scope, not all the scopes available. So you can define scopes, 1,000 scopes around depending on your need. So let's say you have 10 scopes, but you want the user to access only default. So select default, and you want the user only read access. You can provide read access. If you want a DBA kind of access, you can provide read write. Does that answer your question?
Yes, it does. Sorry, I was trying to keep myself on mute.
No worries.
Sounds good. So yeah, let's move on to the app services that I was talking. The piece that is super important to sync up the data in the database in the cloud. So I have created this user profile bucket already. So this is nothing but this is the bucket database where all the data from the end user mobile is going to come here, sync up here. Let's navigate to that and see what are the documents. So there are many configuration related documents because I have already created a app service and linked it here. I'm going to walk you through there. Just before that, let me just query the document that I've already seen. So this is the document that is already synced up in the cloud. So we'll see syncing up back and forth and see how it's changed. So both way we can sync, bi-directional sync, meaning we can update, make a change here, and we can push change all the way to the edge devices, many users automatically. So they'll get an update. That is one way. Another way is user making the update and that is getting pushed here. So we'll see both way. Before that, let's go to the app service piece. So all you have to do is create an app service and create an endpoint. The URL that I was talking to integrate in your Android application. So this is where you define. So just the basic stuff, nothing fancy. You get flexibility of this JavaScript function as well. So while the document is being synced from cloud to the edge devices or from edge to cloud devices, you want to implement certain logic, something to be happen in between. Let's say you want to modify the format of the data or push it somewhere else. Let's say there is some image or something, you want to store it in some S3, you want to push those changes. You can make a REST API call as well here. So you get all sort of flexibility here. In the bit in between, if you need to interfere with the data, you can definitely implement something based on your business requirements. So all you have to do is just create the URL and then define the users. So for this example demo, I've created a user demo at example.com. So this is active. And there are roles. You can create different roles to segregate data, that which particular user is having access to which particular data, like subset of data. You don't want all the user to access all the data, then this is the way forward. So that's it. And once you are done, so that on the right hand side, it shows linked database status. Linked database, we can go to the database. So this particular database is linked user profile. Just to avoid any confusion, I'll delete that beer sample bucket so that we have only one database. We can focus on that. So now we have the user profile database, total number of documents 21. And now let's sync up the data and take a look at it, how it looks. Let me just make it side by side. So left-hand side is the code. I know it's small. Let me see if I can expand it quickly, show you the application. This is basically a basic user profile app. Let me just run it so that you get a fair idea what I'm talking about. I'm just starting the app. Should launch. So yeah, this is a user profile app, and this is the endpoint that I was talking about. So let's go back to here, app services, linked app services. So that it shows which particular app services, that middle tier component that we defined to sync this data from the edge devices to cloud. So this is here we have to navigate to connect and copy this URL and configure it here. So let me configure that. It's already configured. You see 19 ZEI, yeah, left hand side, it's the same URL. So we can go ahead and save this. And I've just pre-populated the app user that I configured without without that particular configuration. Unless we define app user, you cannot access that. So that is a must-have process for security reasons. Once you sign in, so this is the user profile app that I was talking. On the right-hand side, let's go back to the database to see how we sync the data. Okay. So yeah, I'll just open it. So as you can see, this is all synced up. Left-hand side Cinti, the right-hand side Cinti. So this is the document that is stored here. Let me go ahead and make a mistake. Let's say I'm putting a name as James, which is not right, but yeah. Now let's take a look at right-hand side. I'm going to refresh it. Here you go. See how quick is it? It is. So it got synced up. So this is one way. So assume in your store, your workers are using a number of devices and they need to sync up this data. So this is how it will be synced automatically. And all you have to do is just configure that app services that I showed you. So this is one way sync up. Now let's see right-hand side in the cloud database. I'm going to make a change and that should reflect here. So let's fix the name right side, Cindy. And yeah, you can take a look at the left-hand side. So I'm not even going to refresh here or anything. It will automatically change the moment I make update right-hand side. Cindy. And then all I have to do is save. Here you go. So what we see here, it's both ways synced up. Data is synced up both way, from all the way from edge to cloud, and again cloud to edge. Any question?
I have one.
Sure, go ahead.
One thing that hasn't been addressed, or maybe I missed it, but what about auditing?
Sorry, say that. Say that again.
What about auditing? Now, I as a DBA can have pretty powerful rights, but also as a DBA, I'm watched. And generally we have auditors that do that. So is there any type of auditing done or that can be set up within Couchbase?
Yeah, there are like monitoring, there are a number of configurations here. So here you should be able to see all those details, how you configure, but this is just for observability. So
No, there are ways to
there are
audit using,
alerts.
yeah, alerts, logs get written up, and then
This is
it's
the
in the
activity
logs.
log. Yeah, this is what you were asking, I think, activity log.
Yep.
So see, I deleted a bucket, so it got logged. User Abhijit Bera deleted bucket. What time? All this.
Okay, and then how about when you changed Cindy to James, and then from James back to Cindy, did that get logged?
Yeah, that gets logged as well. And there are metadata as well, the revisions and all Let me navigate to that. So this is the document, and these are the metadata. So you can configure here what all item you want to maintain in the metadata, and it has the history of the revisions, how many times the revisions occurred. So you can see how many times I updated before. That's why you see a number of entries. So we can definitely configure that. For this demo, I haven't yet configured, but you can configure here, define it, and you should be able to recover all those auditing as well. Any other question?
There's also the access, the logs have got, there's a humongous amount of server logs also gets captured, and they can be viewed through Prometheus and Grafana. We have a Grafana Prometheus exporter that you can directly get from the Grafana display. You can see all those information as well.
Okay, all right, thank you.
So yeah, that's it. And what else? Yeah. Any developers here? Anyone interested looking at the code?
No, I guess not. Okay.
I take that as a no, or else, yeah, I could have shown you the configurations related to app services. So yeah, it's pretty simple. Just 3-4 lines of configuration, and that's it. You are good to go and have a full-fledged enterprise solution to sync up your data from edge to cloud.
Yeah, the whole flexibility issue, right, comes at how fast can you change the schema? How fast can you, in relational world, because it's developer centric, this one is a fast development, right? So in relational world, I spent a lot of time trying to do the adding column in the waterfall method, trying to get it, from lower to production environments. But here, you can simply go into a document and add a field, add an attribute. There's a whole lot of flexibility things we can talk about during the analysis part of your use case, as well as the modeling part, which one goes in where. Like for example, right, I always use this example with Amazon. It always impresses me that when you go in and say, hey, last June of 2022, I ordered 15 items in a single invoice, show me, right? It just goes and gets you all that items and also the pictures and everything. It's really quick in that, because it's all stored in JSON and document format. So it's really, really fast in how you can get this information.
Awesome. Thanks, Narendra. And Ross, I think that concludes our piece. I'm not sure if we have any more questions. We can certainly open up the floor. If there's a no, well, thank you guys. Really do appreciate Janine, Matt, Robin, as I see here. Really thank you for taking the time to learn about Couchbase.
And thank you as well. Thank you all for coming out and presenting tonight.
Yeah,
it was a great great topic, great presentation. The before everybody leaves, just wanted to announce that next month, July 13th, will be RJ Nowling will be out here to present on change data capture. So thank you all for attending tonight, and we'll see you next month.
thanks everyone.
Thank you.
Thank you.
Thank you.
Thank you.